Hi, everyone. My name is Christopher Earls. I'm here at Embedded World with the Embedded Kit. We are a group of engineers who specialize in developing software. And today we're going to be talking about Yocto, which is one of the pieces of software that we specialize in here at the Embedded Kit. Um, and whether you should be looking at using Yocto as your build system for your future project. So we're going to ask, what is the Yocto project? It's a free and open source set of tools that are supported by the Linux Foundation, based on OpenEmbedded and maintained by OpenEmbedded at the base level, at the OpenEmbedded core. And it allows for high levelability of flexibility and customization within your build environment, because there's a large community that is backing this project, whether it be silicon vendors, SOM makers, software editors, and other developers, whether it be from low level to high level of software. So you pretty much have at the bottom here the core of the project, which is the OpenEmbedded core, which includes all the tools and base level the base level recipes and code required to start and run the project. And as you go up higher, you get more and more specialized. So after you go from there, you get your Yocto specific layers, which are based off of the Meta Yocto. And then you go to your hardware specific levels, which is, say, for example, Meta Freescale, Meta Intel, Meta IMX, Meta Xilinx. These are your hardware based ones developed by silicon manufacturers. So that way, all of the hardware that you want to run on is accessible by your Yocto project and your embedded Linux image by the end of this project. On top of there, you have your commercial layer, which will allow for your software solutions to be installed inside of the system. This is where you find yourself installing frameworks such as Qt, frameworks such as GNOME. That's not a framework, but you'd install GNOME here. You would install your software layers. You'd install your browser if your software requires a browser, for example. You'd install your update software here. Really, the possibilities and combinations are endless here, because this is what you're going to be using for most of your image. And then at the very, very tippy top is the developer specific layer, which is the layer that you kind of provide to the image at the very end. This is where you're going to include your custom software. This is where you're going to include you as a image developer, what you want in this image. This is the software that you provide to the big picture here, that runs on top of everything here. So that's just a kind of a brief overview of how the Yocto project is structured and how all the little tiny pieces come together to create your embedded Linux image here. But now you're probably going to be asking here, why can't I just use something off the shelf here? Why should I use Yocto? Well, there are a few pros here that I like to say, at least. One of them would be that it allows for fine-grained customization for lightweight systems. So say you're running off of a really hardware-constrained environment. You're running off of an ST Linux chip. You only have so much space to work off of for your image. And if you include GNOME, you're going to be getting a lot of junk software in there, such as the GNOME games. And do we really need games running on our embedded Linux software? Probably not. So you can really take the junk that comes off of a pre-built distro and have the very minimum amount of things that you need on there. And that also helps with security as well, because you have less things to manage vulnerabilities on. Another benefit is that you're easily able to integrate onto multiple hardware platforms. Say you have coming back to the ST, you have an ST platform, and later on in your company's life cycle, you decide, hey, why don't we give Xilinx a try? Why don't we try IMX8? and you're able to take your old legacy platform and you could easily port it over just by swapping out the few metal layers, making a few changes, and most of the hard work and heavy lifting is already done. And coming back to this, your system configuration is already centrally managed. So even if you do have multiple different hardware platforms, most of your configs are already set up, and you won't have to go ahead and change configs whenever you decide to spin up a new image, or you get in a new Raspberry Pi, for example. Whenever you get a new Raspberry Pi, it always comes with a stock image from the manufacturer, and you're going to have to go in there. You're going to have to enable your SSH. You're going to have to enable your I2C, and it's a very time-consuming process to take an off-the-shelf distro and to really tailor it to your needs. When with the Yocto project, you can just say, take the image that your system built, and you just flash it to your device, and all your configurations are already in place. You don't have to worry about tweaking configs, going into Nano and hitting the config files, and maybe you miss an error there and you have an issue with your system. Not a problem anymore. Yocto takes care of all that for you. And another benefit here is that 90% of this stuff here is automated. Once you take care of the initial setup, the grand majority of the process is automated for setting up the configs and installing and adding packages to your system. It's all going to be built in once you flash your image onto the system. The other 10% of that is probably flashing your devices, but that's really not covered by the Yocto project. So unfortunately, can't help too much there. But the few cons that come with Yocto is coming back is the build time. If you have certain packages inside of your system, you can find that it might take hours for it to build your image for the first time. So packages like Chromium, GSLang, a few other major system packages that, because everything is compiled from scratch, these can take hours and hours and hours to build if your hardware is not a supercomputer, for example. For example, I know that the Google Chromium packages takes almost 12 hours to build on some of my hardware. So it's something to keep in mind that you'll have plenty of time to drink coffee during the day when you're trying to build some packages on Yocto. Another thing is that there's a bit of a learning curve to Yocto. There is a lot of tweaking, smaller configurations to get the exact output that you want. So you need to know how to structure your recipes, and you need to know how to include certain commands into your recipes. Say there's a recipe you need for a foreign language keyboard into your system. It's not exactly terribly off the shelf. There's a bit of tweaking that needs to be done to do that on your system. And you might even have to craft your own recipes to get the output that you want. At an organizational level, you'll have to know how to create your own recipes for your own meta layer to install the software that you're developing on top of the Yocto project, because this is how your software will be deployed to the system at the end of the day. And again, it's not exactly off the shelf, so you lose a bit of the support that you would get from an off-the-shelf distribution if you could buy that support. Everything is managed by you, and at the end of the day, you have to you have to maintain and make sure that everything is properly set up. So, and if that's the case, we can look at what other options we have to build the Linux systems in the world that we have today. We have Debian, which is free with a cooperative governance. It has a large community that maintains it. Many distributions are based off of Debian. It's a very stable system. So Raspbian, Ubuntu, and Kali Linux, all three of those and many, many more are based off of Debian because of this. It has a very nice package manager. There's about 65,000 and more packages available, with more being added every day. So you have a large software catalog to go through. But there's no dedicated branch for embedded Linux, but it can work if you make a few tweaks, if you add a few things, such as in the case of Raspbian. Additionally, for example, again, we have Ubuntu here, which is built off of Debian. So you have all the features of Debian above here, and it has a commercialized version maintained by Canonical. So this commercialized version will have support. You'll be able to contact Canonical if you have any questions. It also adds the benefit of utilizing the Snap Package Manager on top of apt. So it acts as kind of like an app store. And there's also the containerization system that Ubuntu supports. And you wouldn't be able to get as much of this with Yocto. You could get apt package management on Yocto, but that's a very hairy solution that requires a lot of work and maintenance on your own end. So going on. So what's some benefits to using Yocto now that we went over what the commercial solutions have? Long-term support is available for 4 years on dedicated branches. We have about 6 months left on Kirkstone, and we have another 2 years left on the Scarth Gap. And it's very easy to come back up and update your system step by step by step. Another additional benefit is that coming back to the long-term support and security updates is that Yocto can be configured to make and tailor update bundles at your image build time. So depending on what meta layers that you introduce into your project, for example, you could add Rock, you could add Mender, you can add SW update into your system. And depending on how you configure your configs for the Yocto project, it will generate the update packages based upon your software update solution. And these can be deployed to your devices, and you'd be able to update based on the new image that is built with the update bundle that is generated by these meta layers. Another benefit is that Yocto allows for multiple architectures to be defined for a singular project. So looking back, we have the IMX platform, we have the ST platform, and Yocto can build both images at the same time. So you have pretty much a cross-platform solution here. You don't have to worry as much about creating all these different images when you can use one image to create both images for different hardwares. It's also cross-platform. So you can build a portable SDK for your developers in-house that will allow for them to install on their machine and be able to compile as if they were running on hardware themselves. So you have a program that you need to compile on Linux, on your Ubuntu development machine, and you're working off a Raspberry Pi ARM64 machine. Well, it's a little hard to cross-compile, and you don't know if you're going to have all the tools. So Yocto will enable you to create the SDK with all the development tools necessary to build on your x64 machine as if it would run on the ARM64 machine. And additionally, there's a decent amount of documentation, considering that this is such a large project with many different hands touching it. There is a lot of documentation because somebody has to be able to pick it up and work with it. There's a large community support, so you have many different developers from many different pieces of hardware, software, and they're all working on this. You have many different software vendors and hardware vendors supporting this project because it's in their best interest that there's one unified tool to bring everything together. Another benefit of using Yocto as well is that there's good portability. The ability to create a build system can be very time consuming initially, and deploying it across multiple different systems to multiple different developers, it can be very time consuming. So the nice thing about Yocto is that if you take a container, like a Docker container, and you set up everything inside of there so that all the software required to run Docker is in there, and it pulls all of your meta layers and configures them into the right location. You could easily just take that Docker image, give it to a new developer, and then you can just start building right then and there. So it's fast to set up after your first setup. And patching is always a benefit to Yocto, as well, as you can backport updates and patch system functionality in applications with a drop-in recipe. So say kernel 6.0 has a feature that you need on kernel 5 for your PWM fan. You can take those files and bring them into your kernel by patching into the old kernel. Now, I can't say that it will work all the time, but with a little tweaking and tinkering, you might be able to get something working on your system. So we'll go back into how does Yocto work. So we're going to start at the top here. We have meta layers that host the packages. These are your layers that host all of the packages inside of your system. So meta IMX, meta OE, these are all of the big folders that contain all of your packages that are inside of your system and the packages that you want. And inside of those meta layers, you have recipes. These are the instructions that build the packages. So if you look over here on the right, we have the I2C dev tools for Linux, and this was taken from Meta OpenEmbedded from openembedded.org. And this is an example of a recipe that takes code from both GitHub and local patches to create the I2C dev library on your system for your embedded Linux project. And it will install it with all the necessary configs and licenses inside of your system. So on top of that, you have recipe appends, which we don't see anything here for, but these are files that you will add into other layers to modify the functionality of the I2C dev tools, for example. Say you need to have it on a specific timer or a specific pin, or there's something wrong with the base dev tool that doesn't work for your system or for your BSP. These patches will allow it to work on your system, or add in configs that will allow it to work on your configs. And then you go another higher level, you have the package groups, which define a group of packages and a group of recipes that kind of groups them into one. So if your system requires 5 packages for a base system to run, you could create a package group saying base package group, and that will be a grouping of those 5, 10, any amount of recipes into that package group. And you could use that inside of an image recipe to create the recipe, the image. So the image recipe will take any combination of package groups and individual recipes, and this is the big recipe that will take everything and kind of bring it all into one image. And this will be the image that your system uses. Another thing that Yocto is based off is configs. So you have your layer configuration coming back from your recipes, and these set the requirements for your system. You have your machine configuration, which will define the device trees. This will define functionality such as your U-boot configs, your kernel. And an example of this you can see here. This is the Raspberry Pi 4 64-bit configuration from Meta Raspberry Pi, taken as an example. And then you also have your distro configs, which contain your locale, your languages, and any small bits of information that your distro would require for operation. Yeah, that's faster. So looking at the time. And the final piece of this puzzle is bitbake. This is the command line tool that is used by Yocto to build recipes, build your SDK. This is the big piece of software that kind of takes everything and brings it together. It's compatible with many different fetchers: Git, SVN, FTP, HTTP, HTTPS, wget, pretty much any fetcher that exists, it can use. And It's compatible with Python's. It's mostly built in Python. So you can append Python scripts to your build environment and it will run this. And it also offers cross compilation and native compilation. So cross compile to this target system and it will also compile native 64-bit x64, yada, whatever. So where do we go from here? Now that you know all about Yocto and the pros, the cons of Yocto versus building something taking something off the shelf, why not have a little bit of the best of both worlds and look to talk to the embedded kit? We provide a production-ready Yocto that is tailored to your device for security, OTA, and your BSP platform.